This antiderivative should cause you some trouble in your thinking. If we try to set the top, since it has the higher degree, as u, then the du would end up being in the denominator. And if you remember from an earlier video, I've said that that cannot happen. We want to make sure du never happens, or never ends up in the denominator, that that's something that never happens. So if we look at this, our most logical choice therefore would be to make the bottom the u, but we don't get anything like the top. We get a constant for a derivative then, nothing that's second degree. So how might we go about rewriting this kind of an integrand into a form that we can actually deal with? Well, when the top and the bottom of a rational expression are the same degree, or if the top is of larger degree, we can use long division to try to come up with an equivalent expression that will have, of course, the same antiderivative, but will be much easier to anti-differentiate using the rules that we have. So let's consider for a moment x minus 1 divided into x squared plus x minus 1. You can also use synthetic division for this, whatever you like. I think it's usually easier to see this and to remember it if we do it kind of longhand, but if you remember your synthetic division and you're still familiar with it and comfortable with it, go right ahead and use that. We take the x from x minus 1 divided into the first term x squared. It goes x times x is x squared. X times negative 1 is minus x. We're going to subtract all of that. So x squared minus x squared is 0. X minus a negative x is x plus x, or 2x. And we get 2x plus 1. If we divide x into 2x, we're going to get a plus 2. 2 times x minus 1 is 2x minus 1, or minus 2, excuse me. We're going to subtract all of that. 2x minus 2x is 0. 1 minus a negative 2, same thing as 1 plus 2, or 3. So we'll end up with a remainder of 3 over x minus 1. What this says is this is the same thing as the antiderivative of x plus 2 plus 3 divided by x minus 1 dx. I'm going to break that into two pieces. The x plus 2 part and the 3 over x minus 1 dx part. Because the second part here we're going to need to do a u substitution on. So if we let u be equal to x minus 1, du will be equal to 1 dx. But we really have 3 dx there, so 3 du will be equal to 3 dx. And we end up with the antiderivative of x plus 2 dx plus 3 times the antiderivative of 1 over u du. That's going to give me 1/2 x squared plus 2x plus 3 times the natural log of the absolute value of u plus 3, which is 1/2 x squared plus 2x plus 3 times the natural log of the absolute value of x minus 1 plus 3. Go ahead, take the derivative of that expression and then put everything over a common denominator and see if you can get back to the original integrand.